Wait, you guys can see the web page and this file browsing, right?
Yes, sir.
Yes, sir. Okay, nice. Okay, so for everyone watching at home, welcome to our third session. We're going to talk about JavaScript today. It's very exciting. JavaScript is the language that I have the most significant lines of code written in, probably over 30,000 at this point. And it's also one of my least favorite languages because there are a lot of language design decisions that make it very confusing to learn. So in today's video / interactive session, I'm going to try my best to tell you about those things in a way that you probably wouldn't see in an online tutorial. So again, a big emphasis of what we're doing here. I forgot to plug in my mic. A big emphasis of what we're doing here is that we want to create like a unique experience where you become a really, really good web developer, not just someone who has a little bit of experience and kind of knows what's going on, but is missing a lot of the key details. Okay, so is my mic good, by the way? Sorry, I just switched mics. Yes? Cool. Okay, so first, I'm going to be a little unorthodox. I'm not going to tell you about all these fundamental basic things. We're just going to jump straight into a code example. And then after we do the code example, we'll kind of circle back and talk about what makes JavaScript so different. And then finally, we'll talk about why it's relevant for our website. And then we'll end with a Kahoot, because I'm a 5-year-old at heart. Okay, so let's first talk about how exactly we can add JavaScript to our web page. So I'm going to make just a new HTML file. I'm just going to call it, I don't know, you already took demo.html. Yeah. Example.html.
Sorry about that one.
So, you know, this is a normal HTML file. I think all of you either attended the workshop or have otherwise gone over HTML with me. So this is like no big deal. You know, we can write like something like this. So the easiest way to include JavaScript in your web page is with the script tag. So like any other tag, you know, it's got an opening and a closing tag. But the difference between the script tag and the other tags is that what goes inside here is no longer HTML or just plain text. Now this is going to be all JavaScript. It used to be also other languages like ActionScript, but you don't really do that anymore. Okay, so let's talk about some very, very basic things that you're going to seem very familiar with your programming background in C++ or Java or Python or whatever. So first, comments, I think, are the most important thing you should always introduce first. You have two options. You can do 2 slashes. Is this visible on the screen, by the way? I should have done this before. Yep. OK, cool. So you can do \comment. And if you notice, we can save, reload, like we normally do, and nothing has happened. So far, nothing has happened. Kind of makes sense, right? Next, we can also do block comments with like this thing, slash and then asterisk. This is the exact same as most programming languages, so this is nothing new. And you will find that most of the syntax in JavaScript is very similar to other languages you use. The difference is in implementation and how they work. So we can do that. Cool. But you're like, Matt, this is dumb. I want to do something. So we actually have 2 options. In the notes, we're going to talk mostly about console.log. So console.log is a function. So there's like, this is like the name, if you can think of it as a library, and it's available by default. Dot, if you've done any object-oriented programming, you know, you have like a library, dot something, it's like a property or a function that belongs to that other thing. And then this is a function, so we're going to put in something here. If this is a little fast, don't worry about it. I'm going to double back over this in a moment. And then in here, we can just put something. So I'm going to put a string. We're going to find out that JavaScript supports strings like most programming languages. So we can do this. Finally, I'm going to put a semicolon. This is a little weird. Semicolons are optional in JavaScript. But for our purposes, we're going to say they're not optional, and we're just going to use them all the time. But it's a little weird. We'll maybe talk about that later. So I refresh the page, and nothing has happened. Wow, this language sucks. Does anyone know where I might find the console log, whose name is not Leo, because that would be cheating? Peter, you look like you have your hand on your face. You're in like the thinking mode. Where do you think I could find the console log?
Developer tools?
Yes, Peter. Critical thinking skills off the charts. So as I mentioned last week, the developer tools are really going to be your friend. You're going to use this all the time while you're developing in JavaScript. So if we zoom in here, this doesn't work. So if you look over here, It says hi. I'm not going to use the console for most of this demonstration because you can't zoom, but there it is. So that works. But Matt, you might say, I don't care about the console. I want the user to actually see what I'm going to do. There's two ways we can do this too. I'm going to first introduce a way that you should never use, which is document.write. So again, document is just some other variable, namespace, library. We haven't talked about it yet, but we will in a moment. And it has this function called write, and you can bop something into here. So this time, I'm going to do that. And hi actually showed up on my screen. So what document.write here is doing is it writes to the document. And so it takes a look at where this script tag is and says, hey, I'm going to put where this tag would have been whatever you put in document.write. The reason why I don't normally bring this up is because you usually don't use this feature. There are much better ways, as we'll talk about in a bit, how to actually write text to the screen. However, you'll see this a lot in tutorials, and you'll also see this when it is appropriate for things like jQuery, polyfills, or stuff like that. But don't worry about that. That's not really important. No one uses jQuery anymore. That's also not true. Everyone still uses jQuery. jQuery is dumb. Anyways, so that's one way to do it. For the rest of this, I'm going to then switch to my terminal. And the only reason I'm going to do this is because I can zoom in. But other than that, just pretend everything else I'm doing is in the console as well. So let's do this. So I'm going to go into this thing called Node. This is relevant for the Kahoot. But you can run JavaScript in your browser. You can also run JavaScript not in your browser. We'll talk about more how that works, I think, in Leah's Intro to React session next week, I think. But for now, just take my word for it. You can run JavaScript outside of the browser. This is actually one of the most influential new pieces of technology in computer science in the past like 10, 15 years, I would argue. And has completely changed how we view a lot of things. Anyways, here I can just do the same thing. So this is, I can type in console.log, and then it'll log the thing, and then it'll give me the return type. And this will be relevant when we talk about functions. OK, so Matt, you say, we just skipped over a bunch of random stuff about how the programming language works. So let's talk about some basic stuff you'd expect in your CS31 or Pic10A class when you first learn a language. So what are some things that we might want to do in any programming language? Asking the audience.
Learn about variables.
Wow, Peter. Sequential too. On the dot. Yeah, let's talk about variables. So it'd be very inconvenient if we had to type out lots of things again and again, and sometimes you want to reuse the name. So in JavaScript, the way I'm going to tell you, and this is going to be a common theme. There are many ways to do it, but I'm going to tell you the best practice. So the best practice is to use the keyword let. So I can do let, right? And then we can give this a name, so Peter. And then we use an equal sign, and then we just type in the value of the thing. This doesn't actually make sense semantically, but whatever. OK. Most of you have taken C++ in some way, shape, or form. So I'm curious, what is different between C++'s variable declaration and this variable declaration that we just saw? Any thoughts?
You don't have to specify the variable type.
Yes. OK, so that's a really, really big deal. Right? And this is one of the things that really separates JavaScript from a lot of the other languages that you would have used in your CS career. So JavaScript is what we call dynamically typed, and it's also weakly typed. And those are actually technically two different concepts, but I'm going to explain them as one. So basically the idea is that variables don't have types inherently. You can't declare a variable as an integer or a Boolean or a string. Instead, a variable is just a pointer. There are no pointers in JavaScript, but it's basically just a pointer. And we evaluate the type of the variable every time we use it. So if I do console.log Peter, here we're going to check, hey, what type is Peter? And it should be human, but in this case, it's going to be a string. This is a very, very different way of programming. And it's very convenient in some ways, but it also leads to tons and tons of errors, which is why I personally don't like this feature. And in particular, a lot of developers will write a lot of really bad code using dynamically and weakly typed variables. one thing I want to point out is that this doesn't mean that JavaScript doesn't have types. And this is a very clear distinction. And this is the same thing with Python, which is another dynamically weakly typed language. When I learned Python first, I watched some YouTube video and this guy was like, oh, Python doesn't have types. And that's a really bad attitude to have because, as we'll find out later, not understanding what type your variable is going to change how your program behaves without telling you, which is very confusing. If you're ever confused, you can say, hey, I want to know what the type of something is. So you can do type of Peter. And here it's telling us it's a string. So we know JavaScript supports strings. What other data types might a reasonable programming language support?
Numbers and Booleans.
What kind of numbers, Peter?
Integers or possibly other doubles.
Oh, Peter, you've fallen into the trap of JavaScript. Okay, sorry. So yes, JavaScript does support numbers. However, unlike almost every other programming language that you've probably interacted with, JavaScript doesn't have integers or shorts or floats or doubles. Everything is in this one class called number, which is a 64-bit floating point. That's not really important, but basically it's like a floating point representation. And there's also this other mostly unused type called big int. That's a infinitely long number. So it can be as large as you want. There are some shenanigans you can get into here. So let's do the classic floating point example. Okay, squad, what should this sum give you? Sophie, you're a math major. This is math. What do you think the answer is?
0.3.
You would be wrong. And sorry, Sophie, you're not wrong from a math perspective, but you are wrong from a floating point perspective. So this is something that you'll learn about in CS33 or maybe Pick 10C, I don't really know. But floating point is basically a way that computers represent numbers like under the hood that are very small and use decimals and stuff like that. This is one of the common shenanigans. You can't represent 0.3 in floating point. This will be on the Kahoot, so just letting you know. So we know we have numbers. So if we do type of 0.1, we're going to get number. Note that this is not double, this is not float, this is not whatever. Peter also mentioned Booleans. Booleans are also a data type. In JavaScript, they're lowercase. So we got type of true and type of false. Very exciting. As you might expect, there are Boolean operators. So, true and false. What should this evaluate to? Chloe, I'm going to call you in on this one. This one looks like math as well. I don't really know much about math.
False.
Chloe says false. Okay. Yes, that is correct. We also have the logical or, and this is going to be true. So these operate the same way that you'd expect in most programming languages. There's going to be a fun little shenanigan with this later, but I just want to introduce this to you so you know what it is. What other data types might a reasonable programming language have?
Some kind of undefined type, perchance a null type.
So what happens if a variable doesn't exist, right? What if I do this? It's going to give me undefined. So undefined is a special type that means that this wasn't created. This is confusing. There's another type called null. In my opinion, these could have been the same type, but they're not. Null means that we intentionally put nothing there. So you can never get null unintentionally. The programmer has to do it somehow. Null is very confusing. We'll see some interesting cases of null later. Let's move outside of those. Oh, there's one other basic variable type that Smallberg probably has drilled into your brain in C++. What could that be? Has to do with strings. Sophie, you look like you have like a realization right there.
Character?
Yes. And here's the thing, JavaScript doesn't support characters. So I'm sorry to have disappointed you. On the bright side, JavaScript does support emojis. So in my opinion, it's kind of a trade-off that I'm willing to take, to be honest. So, you can set variables to have emojis. But the normal character operations that you would expect just work as intended with strings. With the exception that you can't like add one to a letter to make it the next ASCII letter. You can't do that. And we'll see why you can't do that in a moment. But you know, we can do something like this. JavaScript has what we call a very rich rich character system. So you can support tons of different kinds of things, you know, Chinese characters, Hebrew, Arabic, right to left characters, all that kind of stuff. And the reason why is because websites actually use that kind of stuff. Okay, anyways, I have made this awkward enough. Let's go over some, what all those variable types that we talked about have in common. And those variable types in particular were string, number, Boolean, undefined, null, and big int. Those are all what we call primitive data types. And you might remember that word from CS31 or Pic10a. That basically means that the thing cannot be changed. And that's a very weird way to describe it. But think about the number 3, right? There's only one 3. You cannot change the number 3. I mean, there's some abstract algebra, the math, there's a lot of math majors here. You guys know what I'm talking about. But the idea is that you can't change number 3 programmatically. And this is the same for a string. So if you have a string object, you cannot change the string. You can create a new string from that string, but you cannot change that string. And you're like, Matt, this sounds so pedantic. But this is actually a really important understanding that people don't have, because this affects how other keywords in JavaScript and concepts like constant variables or objects work. Okay, wow, that was a lot of stuff, and I'm ready to give you some more. So what are some more complex data types that a language might expect? I'm going to answer this one because it's, you know. Arrays are one very common thing. So in JavaScript, we can declare arrays like you would in most other languages, right? So we can do arrays. And JavaScript has what we call heterogeneous typing. So you can put any type of thing in an array. And why would that make sense? Because there's no way for JavaScript to know what type of a thing it is until we actually access it. So to JavaScript, they're just all items in an array. So I can put an emoji in an array, then I can put, you know, a string in an array. I can put null in an array. I can put true in an array. And then if I do that, we'll get all of those things over there. What's something that's similar to an array that you might expect a programming language to support? This one will go back to the audience.
List?
Yes, okay, this is a really great point. So yeah, we would expect it to have a list. Here's something fun that you probably don't know about most programming languages. So most dynamically typed languages, like JavaScript, like Python, actually kind of combine list and array in the same way. Why would that be? Well, if you did not, well, I mean, there's no way you have time to think about this, but if you thought about it for a little bit, right? Arrays in most programming languages all have to have the same type. And the reason why is because in memory, they have to kind of, you know, allocate the amount of bytes possible. But there's no way to know what type of something is in JavaScript. So in reality, it's going to be an array of pointers. At that point, people are like, okay, this is, why not just go all the way and make it convenient? So arrays in JavaScript are actually lists. They're the linked lists that you learned about in CS32 or Pic10a or Pic10b. And you can do things like insert in the middle, add to the end, subtract from the end, add in the beginning, subtract from the beginning, all that fun, juicy stuff. If you've taken CS32, a list where you can add from the beginning, the end, anywhere, could you create, I don't know, some data structures out of that list? Maybe, perhaps? Peter looks like he's thinking about something. Peter, please voice your opinion.
I'm sure you could, but as a manager, I don't know what those would be.
That is okay. I commend your effort. So if you're not familiar, you could do things like a stack or a queue. This is like a first in, first out, last in, first out. If you don't know what those are, don't worry about it. We're not going to use them that much in web development. But just for your own knowledge, and if you get interviewed, like sometimes I interview in JavaScript. JavaScript's insanely convenient for these kinds of things because it's like super easy. So what do I mean though? You can do array.push, and this means you add something to the end. So I'm going to add, I don't know, 0. And then I'm going to add, I don't know, another emoji. And what it returns is the size of the array, which I can get with array.length. So I have a question. This looks like, I don't know, I have like an object, right? And then I'm calling things that belong to the object. Does this remind you of like a certain kind of way that we can program things, maybe, perhaps? Or not? That is also okay.
Matt, wouldn't that be reminiscent of an object?
Yeah, that would, Leo. Wow, you must know a lot about JavaScript. Yeah, so an array is really an object under the hood, right? Like in Java, like in C++, like these other programming languages that use object-oriented programming. And in fact, everything is an object. And this is kind of the crux of a lot of JavaScript. Every single thing is an object under the hood. So every variable, everything is just a pointer to some object, and the object has like a value, and maybe it has some functions attached to it. So what exactly are objects? A really simple object is like a key and a value pair. So what that means is that, you know, we have like a key is like the name of something. So you can be like name. You can do like Leo. And then we can have another key, age. Are you 20, Leo? You're 20, right?
Yeah, I'm 20.
Cool. Like that. And then if we log KV, we'll kind of get that stuff. I know this is a lot of stuff already, so there's no pressure for you to remember all of this stuff. The idea is just kind of introduce you that a lot of the things will look similar to other programming languages, and I don't really want you to worry about syntax. And you can, you know, access these things kind of like an array. This is if you've used a hash map or a dictionary in like Python or C++, this is the same thing. Okay, that was a lot of words. I want to very quickly now talk about a common mistake that people make. And this is called shallow versus deep copying. So pointers. Who likes pointers? No one likes pointers, except maybe Leo. Leo likes pointers. But pointers lead to some interesting shenanigans. So let's say I want to call this, I want to create this object, right? And this object is going to have another object inside of the first object. Okay, it's like a nested object, right? Oh, I could have called this thing nest. That would have been a good point. Okay. Okay, cool. So this is an object, and if we log the object, we'll see that there's an object inside of the object. So this is kind of confusing. The object's called deep. Inside of the object, there's an object called mirrors, and inside of that, it has a key called are not, and then a value called real. So I'm going to make another copy of this because maybe I want to, you know, do something else with it. I'll do this. This is kind of how you normally do it, right? Cool. So I'm going to log that. Oh, works. You know, everything seems pretty good. I want to make a change to my second copy, right? So maybe I think that, you know, mirrors are real or something. I don't know. So I'll make that change. And sorry, I don't know how to type apparently. Cool. And then I'm going to log deep too, and we've made the change. Life is good. Here's my question now. I'm going to log deep. What's the value going to be? If you've taken C++ classes, I think this is a question they test you on all the time.
It's going to be fake then, right?
It's going to be fake. Why would that be, Peter? It's a good observation.
Deep 2 was just going to be a pointer to deep, the original deep.
Yeah. So even though JavaScript doesn't show you pointers with a pointer type or anything, you still have to think about this kind of stuff. And this is why things get very confusing. So when we did this line, when we made one copy of another thing, that just copies the pointer, as Peter pointed out. So then when we change something by accessing the pointer, it's copying the same object. Very confuzzling. So the question is, how would we actually deep copy something? There's no one standardized way that all browsers support, because Internet Explorer is a garbage web browser. But most web browsers now support object.assign. I included in the notes. This is not too important. And usually I'll just advocate that you shouldn't copy objects anyways. But now you know. Okay, wow, this is getting very long, very dry.
Let me interrupt really quick. Matt,
oh yeah,
I've got a question for you. So
yeah,
if everything in JavaScript is an object, And if you assign one object to another, then it just shallow copies it. Then what happens if I declare a new number to be equal to another existing one? What's going to happen in that situation?
You want to do like this?
No.
I'm confused. What do you want me to do?
Okay, so declare a number, and then declare another number to be equal to said number is what I'm saying. So let num2 equal num.
Okay, cool. What are our thoughts? What is num going to be?
Wasn't it a primitive object? So like, did it not get changed?
Yeah, so num doesn't get changed. So it's a great point, Leah. Thank you for bringing it up. So when you do this, you are assigning another pointer. So 5 points to something else. The thing that 5 points to is completely different from the thing that 3 points to. You can't change it. So this works. So really the shallow copy problem I talked about only refers to objects. Thank you for the question, Leah. Thank you for the response, Peter. Okay, it's 5:30. We actually have tons of stuff to cover. I don't want to bore you too much. Let's talk about some very quick other language features. So obviously we have for loops and while loops, and like JavaScript is like a reasonable programming language, maybe 10% of the time. So, you know, if you want to do this is like exactly what you would expect out of any other programming language, right? So you have like the for, you have the thing like the counter, you initialize it, then you have the condition that stops the thing, and then you have your increment or whatever. And this does what you would think it does. Similarly, we have while loops. It works the way while loops work. I don't know what you want me to say. I guess in theory we should do, I don't know. I don't want to declare another variable. Oh, we have 2 variables already. Very convenient. Yeah, so that works, and then it returns the last value of num. So we have that. We have switch case statements. I don't know if you know what those are, but basically you have like basically like a giant if else ladder. Oh, we have if statements. Sorry, I should have really mentioned that, right? You know, we can do stuff like this. And in this case, this is not going to fire because num is not 42. So yeah, I mean, all of these features kind of work the way you intended, and that's not really the point of this lesson anyways, or this lecture. I want to talk about the stuff that makes JavaScript kind of quirky.
I have a quick question, actually.
Yeah, what's up?
Why does, like, when you type that if statement, why does it return undefined, like, everything?
Oh, this is a really good question. Yeah, so the short answer is that if is not an expression. So some things in JavaScript return something, right? So 3 returns itself, right? If I type in a variable, it returns itself. The people who decided JavaScript just said, we're not going to make if return anything. So that's kind of how it works. And then if you don't return anything, it's not set, so it's undefined. So that's the short answer to your question. The long answer is that if is a conditional flow statement, and there's some interpreter magic going on, and there's some branching, because if you don't follow a branch, like what do you return, stuff like that. So long story short is ifs don't return anything, and this will be relevant in React later. So great question, very good, and you'll kind of run into that. But yeah, sorry about that. That was a long rambling answer. Wow, a lot of stuff going on. Very other just quick things I'm going to point out. JavaScript is like a nice language. There are some nice features that you have. So one of them is the of thing. So you could do like for I equals 0, for I less than size of the array, I plus plus to iterate through an array. But the people who write JavaScript were like, we're super lazy. We're not going to add a type system to our language, but we are going to let you do this. So the of syntax lets you loop through an item, item by item of an array. So this is printing out that array that we made earlier. The of thing is used for what's called an iterable object. The idea is just anything, there's like an order, right? From like 0 to 100 or whatever. And it doesn't have to be numbers per se, but usually we mean numbers. The other cool thing that we have is for and then in. So for and then in works for what we call an enumerable type, which means everything is a name. So that's basically any object. And what data types are objects in JavaScript?
Everything.
Everything is an object in JavaScript. Thank you, Peter. But in particular, we're just going to use that random struct I defined earlier. So if we do kv in, oh no, sorry, key in kv, this will give you the keys of each thing in JavaScript. And again, if you don't remember this, it's not too big of a deal. And if you want to get the items of the key, you would just do kv, which is the name of the object, and then key. Okay. This is a lot. I apologize. It's an hour. It's very hard for me to cover all this stuff and make it exciting. But I promise you it will get sexy soon. Last thing I want to talk about, last 5 minutes, and then we will switch to very quick coding thing, and then we'll do the Kahoot, is, oh shit, I need to do this PowerPoint too. As you can see, I'm a very professional YouTube recording. Let's quickly talk about functions, and then we'll switch gears. Okay, so programming languages have functions. It's very convenient. You can use the function keyword, and then you give your function a name, and then you do a parentheses, and you put in the arguments that you want. So you can have no arguments, and then you just do something in the function. Whoa. So that works. You can have arguments. So if we want to instead change the definition here and we log the message, that works great. Very exciting. And then we'll do so there you go. Ta-da, that works. And if you notice, there are no types, right? So no type here, no return type, no type in the argument. And this actually causes quite a few problems because if someone's using your function, they might not pass the correct type down to your thing. It's very bad, no bueno. So something you have to keep in mind is that not having types can sometimes be very inconvenient. Cool. JavaScript is, this is a lot. JavaScript is what's called a functional programming language. It means a lot of things, but one of the things it means is that it supports this thing called first-class functions. This is probably going to be one of the weirdest things that you might have heard if you've only programmed with C++ or Java before. Basically, this means that functions are like any other variable. So I can create a variable and set its value to be a function. So I'm going to do that right now. So I can do this. If you notice here, I'm not putting the parentheses. So when I use the parentheses, it means I'm calling the function. So the thing that goes there is the thing that the function returns, right? If I'm not using the parentheses, it's just the name of the function. It's like the name of any other variable. So that works. And then I can do hello world, and this is going to work as you want it to. Kind of spooky, right? And you might say, okay, that seems pretty useless. But this actually is a really, really powerful tool. So one really powerful thing that you'll do is called a map methodology or something, I don't know. It's a way that you can go through items of an array and apply a function to each item of the array. So we had this array earlier that has like our simp emojis and stuff. And I'm gonna call map. And you might say, well, map, how would I define what function to apply on each element? And this is where functions, being like any other data type, which are all objects, is really helpful because you can just pass a function as your argument. So the function itself is the thing you're passing, and it applies it on every element. So I'm going to do hello world, and again, not going to type in the parens, right? We're just going to do that, and we'll do that. Oh shoot! Did I? Oh yeah, there we go. It worked. So it logs at every item in the array. This is kind of a dumb example because we could have done this with a for loop, but this is one really good way to make compact arrays, but also just more generally. It's a very, very common programming pattern. And we'll see that there are a lot of benefits of this when we do React and talk about like parallel processes and just in general, this is like very cool. Egert is a big fan of functional programming. So if you take classes with him, you can be like, hey, I like functional programming. You'd be like, oh, wow, you're so cool. And yeah, yes, and if you've done function pointers, I don't think you cover it in CS31 or 32, but if you've done function pointers in C or C++, it's the same thing. Oh yeah, qsort and CS35L, I think. is the first time we see it. A lot of words going on. Last thing I have to tell you about is anonymous functions, and then we can move on to non-staring at a code thing, and I can show you some memes. If we really thought that functions were just like variables, we should be able to make the entire right-hand side of an assign statement a function, and that's exactly what we can do. So we can do this. Notice here, this function has no name. So it's an anonymous function because it's no name. This is a dumb function, but we can do that. And then if we call weird, right, we're going to get the thing back. And so this thing on the right is called an anonymous function. It doesn't have a name. It's not attached to any namespace. And the big idea here is that you don't have to now define some random function that you're only going to ever use once. If you want to do something like double every number in an array or sort out all arrays that have even numbers or whatever, you can do all of that and not waste any time. This is extremely, extremely common in JavaScript. And I really want to bring this up because if not, you will be extremely confused. And also we're going to use it if we have time. And yes, as Leo mentioned, this is called a Lambda function in Python. And in theory, you can do this in C++ and Java, but not exactly. In Java, it's like super sketchy. In C++, it's like kind of sketchy. But in JavaScript, functions are first-class citizens. So they get all of these benefits. Wow.
Wait, so how is it anonymous? Because doesn't it have the name weird?
Oh, okay, sorry, yes, that's a great point. So this portion is the anonymous function. So this thing right here doesn't have a name. We're giving it a name, weird, but that's a great question. So how would we actually use this? You know, we can do array.map, and then I can paste a function in here, and this function has no name, right? We're just using it for the map, and then I just use it. And I mean, that just returns the same thing because it's a dumb function. But does that make sense? So this part of the function doesn't have a name. Cool, cool. Oh, I used an optional semicolon here. Matt. Okay, I'm pretty sure that's everything we need to cover. The README notes are pretty long. It's probably going to take you like longer than it took me to explain this stuff. So I apologize, but it's a lot of stuff. Okay, cool. I'm going to quickly switch to this PowerPoint that's memes about why JavaScript is a bad language. And then we'll do the Kahoot. And then we'll end off with some DOM stuff. And it's not that kind of DOM, if you were wondering. ACM is supposed to be a PG-13 YouTube channel. I shouldn't have said that. Okay, so we're only going to do the first glance today. But we're going to talk about what makes JavaScript a different language than normal. So this is like some random stuff that you can find on the Mozilla website. Mozilla is an open source company that is about the web. They make Firefox, and they also are a big contributor to JavaScript, the language. This is a bunch of random words, but we actually talked about some of these today. So it's interpreted. I guess I should have mentioned this earlier. It's not compiled, right? We didn't compile any JavaScript. We didn't open up Xcode or Gradle or Maven or all these other kinds of things. It just kind of runs in our browser. And this means that the language kind of interprets it line by line. This is not entirely true. You can compile JavaScript, but for now, we're only going to touch the interpreted version. This means that you can't do things like catch bugs at compile time because there's no compile time. So that's like not good. It's not good for error catching, and we'll kind of run into that a lot as JavaScript developers. We said it's first-class functions, so we talked about that. Look at us. It is prototyped based. We did not talk about this. This is actually kind of complicated. This has to do with how object-oriented programming works in JavaScript. Maybe we'll talk about it another day. Multi-paradigm just means it can do many things in different ways. Single-threaded, we'll talk about this, I think, in like 3 weeks from now. Dynamic language, talked about that. Object-oriented, we kind of talked about that. Imperative is like your normal C++ line by line kind of execution thing. And declarative, we didn't talk about that, but don't worry about it. E.g. functional programming, which we did talk about, styles. I'm not going to quiz you on this, so don't worry about it. It's not in the Kahoot. Oh man, that was the slide I was supposed to use. Okay, so this is not that important. We're not going to really worry too much about how JavaScript works yet, but the big thing you need to know is that because you can't compile it, it's kind of tricky to catch errors. So you can run JavaScript code in your own website and it works perfectly fine, but that doesn't mean that you're not going to have type errors, right? Maybe you just didn't do the right interaction to create that error. So when you make websites, you kind of have to make sure that you do a great job of testing all your kind of stuff so it works out, because the language doesn't do it for you. As we talked about, JavaScript is dynamically typed. Here I'm going to introduce the idea of type coercion. And this is a very confusing part of JavaScript. Basically, let's say you want to do a number plus a string. That does not make sense. In other languages, like Java, actually that's not true. In other languages, like C++, that would throw an error. They would be like, oh, you cannot do this. That's bad. Stop. JavaScript does not care, okay? It's just going to do its best and run as best as it can. So what it will do is actually try to convert the types of other things so it all lines up. Very quickly, the hierarchy is string is best, then number, then Boolean. I think I have this in a later slide. And that'll become relevant when we look at some means. As we mentioned, there are primitive types. I didn't talk about symbol. We don't have to talk about symbol. It's not very important. And as I mentioned, they're immutable, so you can't change them, and that changes the behavior of stuff. As we talked about, everything is an object. You can read the slide later. It's not super exciting, but things like numbers, objects, arrays, functions, all these things are objects, and we have to think about pointers and stuff like that. This is the shallow copying error. And then as we said, functions are just like anything else. Okay, we're zipping through this PowerPoint. I think when I did this with the teacher-led dev team, this was like 30 minutes. That's functional programming stuff. We're not going to worry about that. It's a lot of ooh-woos. Cool. We're not going to, I think maybe we'll talk about this another day. But functional programming is very cool. If you're interested, you can talk to me about it more. I like functional programming a lot. I'm a big fan. But it's a very cool paradigm, and it leads to some really good performance benefits. This is one very quick thing I'm just going to mention. JavaScript is garbage collected. So what that means is that you don't have to like delete memory, allocate it. It's very convenient. I don't know if any of you did the CS32 thing where you have to make the game and it's tons of work. And you're like, wow, this sucks. I hate it. And you don't have to do that. It's nice. JavaScript does it all for you. And this is called garbage collected. Let's talk about types. Okay. So as I mentioned, you can use type of to figure out what type something is. There are some special values. So the first kind of special value we'll talk about is falsy versus truthy. This is kind of dumb. So the idea is that, let's say you have a Boolean comparison, right? Like and or logical or. But the thing on the left is not a Boolean. In other languages, actually in most languages, it'll convert it to something else for you, right? If you do if 0, in a C or C++ programming language, actually, that's a really bad example. If you do if 23 in like a programming language, right? It converts the 23 to true under the hood. You've probably used that behavior before when you check if something exists. If you do if null pointer, that converts it to false, right? These kinds of things. So JavaScript does this too. It's called type coercion, or with falsy values. So the values that are false, you don't have to remember this except for the Kahoot, are false, 0, 0 the big int, null, undefined, the empty string, and not a number. Not a number is the value you get when you do dumb things with numbers. So you divide by 0, it's not a number. If you try to subtract the string mat from the number 1, that's not a number. That doesn't work. As a fun fact, not a number is a number. That's so dumb, right? Anyways, so you can't use if the thing is a number or not a number because it is a number. There's a function called isNaN. Why? Just why? So we can see here are some examples that I did 3 months ago. Null is not equal to false. Null is not equal to true. How? What the heck? The answer is that null is only equal to itself. But it does get coerced into values. So if null, print something, we don't print anything. If not null, print something, we do print something. So that's so dumb, right? So null is not false. But if you use null in an if statement with the exclamation mark, It is false. What the heck? JavaScript. Similarly, same thing with the ands, right? Null and null returns null. True and dog returns dog. So this behavior means that if and will return the first thing that's false, right? Or the last thing. So this time it returns the last thing. This time it didn't return the last thing, which means the first thing is false. But here it says null is not false. I hate this language. I hate this language. Okay, so that's what we talked about with type coercion. If you don't want to coerce types, you can use the equal operator or the exclamation mark equal operator, which is lots of work. But most of the time, you should use this because usually type coercion is not what you want. Sometimes it is what you want, and then you can use it accordingly, but so that you know. And as I mentioned, the priority is string, number, Boolean. It will become relevant in our Kahoot. Okay, let's look at some other dumb examples. So you have the string 42 plus the number 0. This gives you the string 420. Why is that? Well, we have a string and a number. We have two options. We could convert them both to numbers or both to strings, but we like strings. So we're going to convert them both to strings. So we have the string 42, the string 0. Then we add the two strings. It's like concatenation, right? So you get the number 420. But if you do subtraction, you can't subtract a string and a string, right? So it's going to convert them both to numbers, okay? Similarly, you cannot subtract or multiply a string and a string, because it's going to convert them both to numbers and then do the multiplication. This is really dumb. If you try to add a number and an array, it will convert them both to a string and then concatenate them as a string, even though there's no string here. Notice that none of these things are strings, and somehow we got a string. Here's the really fun one. Look at this, 42 plus false, okay? Well, false will get coerced to 0, and then it becomes 42, which is not the behavior that I think intuitively most people would expect. But if 42 is a string, then we convert them both to a string. And you're saying, Matt, you know, you're really getting worked up for something that doesn't seem like it's that big of a deal, okay? Let's look at some other examples here. What is this? Do you see this? What is this? How is this valid code? Okay, this is ridiculous. 5 plus minus plus minus minus plus minus minus plus plus. This is ridiculous. Just to tell you what's going on here. The minuses are being interpreted as minus minus, like take a variable and subtract 1 from it. And the plus plus is being interpreted as take a variable and plus 1. So all of these things cancel out to 0. And then there's 5 plus the string minus and then plus the string 2. So now you know. Super dumb, right? Look at this. This plus plus gets converted to bar plus equals 1. Bar is not a number, so you get not a number. And you convert them to string, so you get foo nan, which doesn't make sense at all, because there's no number involved in any of this. This is ridiculous.
So Matt, I see you getting worked up about all these types, all this type coercion. What do you recommend we do every time if we want to avoid dealing with all of this whack coercion?
Please type your stuff. Like use types properly. Do not do this stuff. Use equals, equals, equals. Use exclamation mark equals, equals, etc. This is really dumb. Look at this, okay? Null is not greater than 0. It's not less than 0. It's not equal to 0. But it's greater than equal to 0? Really? Really? And what's going on here is that this operation typecasts, but this doesn't for null. So now you know. It's controversial. I've not really proposed the other side of the argument. I've not been very fair, but it's controversial. You know, some people don't like it. Here's one of my favorite memes. So 0 is equal to the string 0. Okay, 0 is equal to the empty array, because empty array is falsy. 0 is falsy. That's true. But the 0 of the string is not equal to the empty array. So equalities are not transitive. If you've taken an upper div math class, you know what that means, right? Just because one thing is equal to another thing and that other thing is equal to the other thing does not mean that those two things are equal. So A equal B, B equals C does not imply A equals C. This is extremely confusing because you'll probably use this in your code all the time, especially as a web developer. So you need to keep that in mind. This is like my least favorite page of all time, okay? Let's just go through some examples of why JavaScript is dumb. So nan is a number. This number is not equal to itself. This number is equal to another number. The largest number is negative infinity. The smallest number is positive infinity. If you add two empty arrays, you get an empty string. If you add an empty array and an empty object, you get an object. But if you switch the order, you get 0. So we now know that addition in JavaScript is also not commutative, right? A plus B is not equal to B plus A. True minus true is 0, and true plus true plus true is 3. Intuitive, of course. Who would not expect that? This ridiculous thing creates an array of length 9. I hate this language. Okay. We didn't have that much time to talk about var, let, and const. So as I mentioned, let means the thing is block scoped. It works like every other programming language you would imagine. Var is function scoped. Don't use var unless you know what you're doing. And then constant means that you want to make the thing a constant. The thing I'll point out very quickly is that const is only for the pointer. So you can't change the pointer, but you can change the stuff that the pointer points to. That's like the very important thing. Yes, this is a function. We talked about functions already. Constants. So if you notice here, we set pi. You cannot reassign pi. That's cheating. You can't do that. But you can do it with objects. And the reason why is because the pointer doesn't change, but the thing inside the pointer changes. So this is also important. You can't really use const on an object. There are other guarantees you have to use, things like redux, for example, or immutable, to really make an object constant. We're not going to talk about this. That's too much work. We'll talk about that another day. Okay, team, it's 5:57. I'm really sorry. I did not manage my time properly. However, I have a reward, and the reward is a Kahoot. How do I play the Kahoot? Am I not smart? We're going to play a Kahoot. Get out your phones. Go to kahoot.it. I don't know if I'm going to get YouTube banned if I play the Kahoot music.
I don't think you will. I don't
What is
think.
Kahoot doing?
I'll look right now for
It's
you.
working. What? Oh! What happened? Where did my Kahoot go? There we go. Okay. Team, we're in grade 5. We're going to play a Kahoot. Please join the Kahoot.
As a fun piece of trivia while we're all getting in here, someone discovered that the Kahoot song is made with like default loops from GarageBand.
I kind of respect it.
Yeah.
I see that we have a very lively Kahoot squad of just Peter. Sophie has joined as well.
That would be me.
Okay, let's do it. So this is just to test if you remember the stuff that we talked about. What? Okay, so most of us got the answer right. It is functional. That's what I said. You kind of have to take my word for it, but it supports first-class functions. It's dynamically typed and is interpreted. It's not strongly typed because types are very weak. It's kind of like not a very strict thing that people say. But usually we'd say something like Java is strongly typed. Is everything going okay for you, Nisha?
Yeah, I didn't realize there were multiple, like you could click on multiple things.
Yes. Okay, some of them are multiple choice. I apologize for the confusion. Why does it say quiz every time?
Oh no.
Yes! We all understand this terrible language. Okay, so as we remember, number plus string, coerces to string plus string. So it's concatenation. Great. Ah, so big int strikes again. Yeah, so it sounds weird, but big int actually is a primitive type. Object is the one that's not primitive because you can change objects without changing their point. Peter is in the lead, beating Leo. Yeah, so, tough. Chef's kiss. Chef's kiss. This one's a tricky one. So it's true because 0 and the empty string both get coerced to Booleans, and they're both false. Okay, Peter. See. This is the good one. So yeah, null does not get coerced because null is a dumb invention that languages shouldn't have. So this was a tricky one, right? This was a tricky one. So what's going on here? The 42 minus 1. Okay, so this can only be a number, right? Because you can't subtract strings. So it converts them both to a number. So you get the number 41. Then you add 1, so you get the number 42. This one's hard though, right? JavaScript's dumb. Dude, Peter beating, Peter in the lead. Okay, Leo, I think I might fire you as dev team director.
Sorry.
This one's kind of, if you don't get this one, I don't blame you. I didn't spend that much time on this. Tough one. So yeah, you should use for of for arrays and iterable objects, and then for in for enumerable things. It's not super intuitive, but if you don't remember this, it doesn't really matter. You can always look that up when you're doing development. This is a multi-select, so you have to select. Okay. So mostly we're chilling. So JavaScript functions not having explicit return types does not mean that it supports first-class functions, right? It just means that it's dynamically typed. So are there languages that are not functional? No, but it's not evidence that shows that's the, I guess, Basic allows this, but no one uses Basic. Okay, the classic. Squad. This was a tough one, but yes, not a number is actually a number. It's not good. Oh, Peter overtaking Leo again. Okay. So this one's hard because you might think the triple inequality says, hey, this thing has to be a Boolean. But the pluses here convert this thing to a number, and then you get 4 is equal to 4. So it's a tough one. Skill testing questions. Okay. So this is like for int I equals 0, just to clarify if you're not. So just like in most languages you can't, in C you can't, you get a compiler error if it's before C99. Again, No worries if you don't remember this. So is it true that JavaScript has a garbage standard library? Yes. However, it does have stacks and queues. It doesn't have left pad, which is dumb, but it does have its stacks and queues, because in the array object, you can pop from the back, pop from the front, add to the back, add to the front. Again, not a big deal if you don't really know what this means, because we're not going to use it that often, but just so you know. This is a multi-select. Oh, this is a hard one. Thank you. Thank you. JavaScript is done. Yep. Yes, you can. I don't know if you got penalized for not selecting the other one. I hope you didn't. But oh, we didn't talk about this. This is the answer. This is the answer. I apologize. I was going to talk about it after. I'm sorry.
If you guys are interested, I could always talk about it after this.
Yeah, I'm kind of just, I'm also worried about time.
Yeah.
The other thing is, technically, we actually are not going to use document.getID that often. As Sophie, we will, because we're going to do other stuff. But for React and Learning Labs, not really. This one is mostly good. This is kind of just a technicality thing. But the namespace basically just means it's like the space that has the names. That's not a very great description. But don't worry about it. I'm never going to test you on it. This is kind of just a tricky question. Okay, I think this is the last serious question. It's a multi-select. Yes. Okay, so
That's awful.
So very quickly for these two, so functions are like any other data type. I didn't show you this, but you can have anonymous functions as an element in your array. That sounds confusing, and you will very rarely use that, but you can. This I also didn't explicitly mention, so that's kind of on me. But if you do know what linked lists are, you can have an infinite amount of elements in the linked list until you run out of RAM. Okay, cool.
So not really infinite.
Oh, this is the last serious question. Sorry. My bad. This is a multi-select. You have to select all the ones you believe are correct. Okay, this one was kind of hard, but I'm glad that most of us got most of the stuff. So automatic memory management, we all got solid. So JavaScript can be compiled. I briefly mentioned this in passing, but it can be. Now you know, don't worry about it. This is tricky. So I didn't explain what this meant, which is kind of on me, but it's a Kahoot. So I think it's fine. But I want to talk about this very briefly. So every single browser implements JavaScript differently, which sounds really dumb, right? So some things exist in some browsers, but not others. So one reason why I hate Internet Explorer, other than the fact that it's a garbage internet browser, is that it also doesn't support a lot of new JavaScript functions. So things like map, for example, didn't exist for quite some time in Internet Explorer. And I used to work for a startup where I had to make the website work on Internet Explorer 9, and I hate Internet Explorer. Never, ever do that. I'm not going to make you all support Internet Explorer 9. And we'll have polyfills as part of the build process, so don't worry about that. Okay, great. Oh, I don't think this should have been a multi-select. Actually, no. Yes, it was. Okay, let's show. It's been a long day. It's been a long day.
Oh no.
Thank you. Reputation is Taylor Swift's worst album. Okay. That's it. That's the Kahoot. Let's go, Nisha. Huge flex. Second place, Peter. And Leo, proving that he's the dev team director.
I kind of cheated on this
for a
one,
reason.
but you know.
There we go. Sophie, in my heart, you are also a participant, and that's what matters. Wow. Difficult question. Okay, cool. So that was a long time. It's 6:10. We have two options. One is I can continue the rest of the thing, which is like 5 minutes, or we can adjourn it now, and I'll just push this to another time. What would we prefer?
I gotta actually go and help cook dinner, but thanks for the lesson.
Yeah, no worries, Peter. Thank you
Later,
for
Peter.
coming. Sophie and Nisha, would you prefer if I continue or just kind of delay for later?
I have to go too.
Okay.
I have to go too.
I
Okay.
apologize for the overtime. Thank you all for coming. Really appreciate it. We'll talk about document.getElement by ID another time.
Bye,
But
everyone.
please give us feedback, by the way, because this was a hard lesson to do. But yeah, please enjoy. See ya. And if you're watching at home, please tell me you watched this on 2x speed. I am so sorry. Just some quick things if you're watching at home that I want to talk about. So if you want to learn more about JavaScript, we posted some information in the README notes, and you can go through that. The Mozilla Developer Network in particular is a really good resource that tells you a lot more about how JavaScript works. Some other stuff that just might interest you that we didn't talk about and we won't get to talk about. JavaScript functions have an optional number of parameters and arguments, so you can have as many as you want. And you can have optional ones. So if the user doesn't input an argument, it still works out. You should read the note about document.getElement by ID. And Leo has done a great example of implementing that note and commenting it and telling you how it works. And if you want to learn more about functional programming and why it's useful, and specifically in the context of why in web development it's an important concept, we can talk about it at office hours or at any other time. But in the meantime, thank you for sticking with us. Please watch all our videos on 2x speed if it works out for you, and let us know how we can improve. But that's all. Thank you for watching. See ya.